So would we just start off by drawing like a random triangle?
Yeah.
And then, so the area is half AB, form of area is half AB sine C.
Mm-hmm.
And so do we now need to somehow find an angle for this triangle?
Yeah.
Um, is it a right angle triangle? Because it's a sail.
Doesn't look like a right angle.
Um,
Oops. Yeah, it's definitely not. Close. So you need some equation that involves three sides and one angle.
it's a cosine rule.
Cosine rule.
And that's a squared equals to b squared plus c squared minus 2bc cos a.
Yeah.
And then we have to then rearrange the formula and make it a squared minus b squared minus c squared divided by minus 2bc equals to cos a.
Yeah.
So I got a negative answer.
What answer did you get?
Minus 31 over 360.
I'm in radians. Let's see.
And then I got A is 94.9 degrees.
Sounds alright.
Yeah.
94.9 degrees. If I press answer shift setup angle unit degrees. Too late. I could have just actually. Oh, I can just use that value, I think. Okay. And so area.
So that would be half times 12 times 15 times sine 95.9.
No. Which is angle A?
Angle is 94.9. Is that the angle? Is that not the angle between 12 and 15?
So what did you sub in? What values?
Yeah, I did 20 squared minus 12 squared minus 15 squared all over minus 2 times 12 times 15.
Okay, so you snaked me. Yeah, that should work. Okay, go for it.
And then, so will it be a half times 12 times 15
Mm-hmm.
times sine 94.9.
Mm-hmm.
I think that should be the answer.
What do you get?
89.7.
There you go. I got the same thing. Doing it a completely different way, which was radians, and I did A as the angle in the bottom right corner. Get the
And
same
then
answer regardless.
times it by 4.
Why would you do that?
I thought because it said four identical triangular cells, we had to do 4 times that area.
Oh, you're right.
And so, yeah, that'll be the answer.
Better check. That's question 10. Is this the right one? Yep. Question 10. 359. Yep, it's a 3 sig fig. Okay. Any questions with that?
No.
9 square meters, so meters squared. Yeah. Cosine rule to get the angle, then sine rule to get the area. Okay. How about this?
Yeah, so I'm not entirely. Does angle of elevation mean like so C is going to be somewhere like around there?
Yeah.
Do we have to do a triangle? Yeah.
So this one at A is 15. This one at B is 32.
AB is 75.
Okay.
And so um so if I fill in, should I fill in like 90 degrees?
If you like.
Both sides, yeah, but for both sides. And then, so that means the top angle for the left triangle will be 75, and for the right triangle that'll be 58. Oh, should I now just like add 75 and 58 together? Or that would be
You could. I think you'll just get 180. Take away 32. Take away 15. So 133.
yeah.
Okay.
And do we now? I feel like so. Can we sub in like using to like half A B sine C, yeah. An area, and then sub that into that area equals to base times height, and then just do area divided by base to get the height.
We would need two sides and the angle between for a half AB sine C.
I'm not really sure.
You could do that. You could find a second side. How can you find the length of another side?
Like Pythagoras theorem or something.
How about with the big overall triangle ABC?
So should I do sine rule?
Yep.
And so would that be 100? No, sine 133 over 75 equals to sine 32 over x.
Yep.
And then just put that into my calculator.
Mm-hmm.
I got 54.3. So does that mean that the side on the left is 54.3?
Mm-hmm.
So should we now sub that into half AB sine C?
Mm-hmm.
And so that would be a half times 75 times 54.3 times, yeah. And so,
Times sine.
and um, I'm getting a bit,
a half AB sine C.
yeah.
A half 75, 54.3 sine C.
So is it not 75 times 54.3?
Sine C.
And then times sine 15.
Yep. Angle between them.
And so that would be equals to and I got 527.
Okay.
So do I now need to do 527 divided by 75 to get the height?
What is the area of a triangle?
Base times height.
That's a rectangle.
Oh, base times height over 2.
Yeah.
And so do I now do 527 equals to a half times 75 times x?
Yeah.
I got 14. 14.1, 14.1.
So that is The height is 14.1. We might be slightly off because there was some rounding, but if we used answer, it should be fine. I don't even know. Question 11. We're not right. It's obtuse or something, is it? Hang on a second. Where did it go wrong? That's 15. Angle of elevation. So, angle of elevation, yeah, must be something that I'm not familiar with. So that's how angle of elevation works. So instead of using 32, we should have used 148. Why? Excuse me. Okay, so angle of elevation. So if that's 15 and that's to the church, then this one is 32. This one is 32. So angle of elevation seems to be it starts from the right and then opens up this way.
Okay.
I didn't know that. And then we need to find this here. And so this angle here is 180 minus 32. So that's 148. And so we do the sine rule with that 148. This was base of 75. So this angle up here. Did we have any other? Oh, the distance A to B is 75. So just this in here. Let's see. So how can we find some missing side or something? Let's see. Hang on. We can actually. So what is the angle up the top left?
That would be 17.
And then what's this angle here, given that this is 90 for the height, perpendicular height?
That will that be 58?
And so your sine rule that you said, sine 17 over 75 equals what would it be equal to? Or like for an equation to solve.
So what do you mean when you say like an equation?
So sine rule, or okay, so we have these two like angle and side are opposite each other. What else could you do?
Do I now need to make sine 17 over 75 equals to sine 15 over x?
I believe it would be 15 over this one here.
Oh, right, yeah.
Because that's just a small angle. So sine 15 over, I don't know what to call it. I'll call an MCM or something. Maybe people think it's midpoint CN or something. I don't know. Okay. Put that in the calculator.
Okay, so 66.4.
Say it again.
66.4.
Okay. And what would you do next?
Half AD sine C.
I think you can now get x by doing sine rule with the triangle on the right.
So that would be, do I have to do sine 90 over 17?
Sine 90 is over.
Oh no, not 17. Sorry. Whatever that length is.
This one?
Yeah.
It's this one.
Yeah. Sorry. So sine 90 over 66.4
Mm-hmm.
equals to sine 32
Mm-hmm.
over x.
Try that.
$35.2.
That's great.
Okay.
Meters. Yeah, so I didn't realize. So it's not just an angle of elevation. Start right, open up counterclockwise, and that's called angle of elevation. All right. Any questions there?
No.
Okay. How would you do these?
Is it just calculator?
Yeah, just calculator, I'd say. Let's see this one. So I think this one thwarts you from using the calculator.
Um, do I need to work out what K is?
Yeah.
And so, um, do I need to do like find the gradient or something?
Gradient. I think this is the key here.
Oh, because so that's yeah. So if that's I need to do 0 is equals to sine just K, I think.
What is the x coordinate?
0, 120, sorry, 120 plus k.
Yeah.
Then put that into my calculator.
Yeah.
And that will be.
I'm in radians.
Yeah.
Are you getting an answer for it?
I was on the graphical, and it's always weird when I have to like put brackets.
Yeah, and it gives you loads of solutions and stuff.
It said like syntax error because I closed the brackets 120 plus x and the brackets turned red, so I'm not, yeah.
So all right, we'll do it from first principles.
Okay.
Sine graph usually looks like that. What's this coordinate?
0, 120, 0.
Like y equals sine x.
Oh, y equals to also 0 equals to sine x.
Okay. What x? It's a normal sine graph.
Oh, is that like 180?
Yep. And so this is usually 180 0. On this graph, it's 120. So what must k be?
Minus 60.
You would think so, but it moves it to the left by 60.
So does that mean that k is 60?
Yeah.
Okay.
X plus 60. So I believe k is 60 degrees. B.
Can I now just put sine x plus 60 into my calculator and get all the answers?
I believe so.
Okay.
So it just moved everything 60 to the left.
Yeah.
So that's usually at 90. So I think it'll be 31. So you can check with your calculator. I think that one's 31. The smallest value of k. Wait, what? Did I mean the smallest value of y? So did you get values?
So I'm getting. So for y-intercept, I got. I had to get coordinates of d.
Yeah, I think they're 31. You check.
Do you know how to adjust it so I can see it as a curve? Because right now it's just like a straight line.
Change your view to trig.
So what do I need to do, sorry?
So you change the view to trig. So go to, hang on, sine x plus 60. So I'll draw my one. So I have the same thing, straight line.
Yeah.
Shift view window. Let's go with trig, F2. Hey, that's not bad.
Yeah, that's better. Yeah. So they asked for D, which is like the top of that. Um, so is D just like that little bump next to the one?
Mm-hmm.
And so is D going to be like something 1?
So shift,
Yeah.
graphical solve, F5.
Yeah.
Which one?
Max.
Yep.
And J 31. Yeah.
You just press right. Yeah, so that's 31. How about y-intercept?
G solve y-intercept, and that is. They didn't ask for an exact value, so I think I'll be okay here, right?
Yeah.
I got 0.866.
0.866. I don't understand the smallest value of k, to be honest. I thought k was a constant.
Yeah.
Do they mean y? I mean, k is 60, isn't it? Oh,
Yeah.
oh, hang on. The value of p is what we were asked for at the beginning. Did we find p?
No. So I think P would just be the root. So I think that P is just 300 0.
So p is 300 degrees. Okay, so I think k is probably 60. And then the value of q we got. Q was y-intercept. Sorry, that goes there. Coordinates at D, 31. All right, let's check this out. 14. Yeah, trig, that shift view trig makes things easier. P is 300, 31, K is 60, and then Q is root 3 over 2. It did seem like something like that. I thought we could get an exact value. It looked kind of familiar. Just in case they ask for an exact value for Q, let's see. Make X 0 and solve for Y.
How do you get Q, sorry?
It's when X is 0.
Oh, yeah. Yeah.
And so it's just Y equals sine 60, I think.
Yeah.
Oh, I'm still in radians. Yeah, root 3 over 2. Great. All right. Any questions there?
No.
Okay, not bad. Oh, what is this? All right. How do we do this?
Um. So do I need to sub in at 36 into sine P? Do I need to like sine 36p?
Okay.
Should I make y 0?
Yeah.
And so just solve for P.
Yep.
And that will be.
I think it. Okay. Is it any good?
So I got not really. It gave me quite a lot of solutions.
I'm surprised. Like 0, 180, stuff like that.
It gave me like minus 20, minus 50, minus 10, minus 5, 0,
What's after 0?
5, 10, 15, 20, 25.
So P might be 0. Oh, sorry, P might be 5. Let's take a look. So this is the usual sine graph. The closest points to the origin that the graph crosses the x-axis has x-coordinate of 36. So I think that's wrong. I think except for 0, 0. Because that is the origin. But okay, so like after the origin, let's say. So normal sine graph, what is the next point that's closest to the origin that crosses the x-axis?
The midpoint.
Yep. What is that coordinate?
That will be so y is 0 and will that be 36 0? Oh no, will that be like 5 0 or something?
This is just a sine graph.
Oh, sorry. So that'll be 180 0.
So that's 180. And for this new graph, this 180 becomes 5. And so 180, or let's say 5 times what gives you 180? No, sorry, 36. Sorry, 36.
So we've got 36.
So 36 times what gives you 180?
Five.
Yeah, P is 5.
Yeah.
There's no way around it. But if you're given lots of solutions, you don't know which one to pick. That's the one. B, what about this one? Period of f of x.
What was period again, sorry?
How often it repeats.
Oh, so period of x. Oh, can I just like draw the graph? Oh, like use a graphical calculator to see.
Yeah.
And so that would be. So am I subbing in sine 180?
No.
Is there not? Oh.
If you're using your graphical calculator, it would be y equals sine 5x.
Sine 5x. Right. That will be pretty frequently.
What is the period of sine x?
Do I need to go back and draw the graph for sine x?
How do you not know this?
Sorry.
How often does sine x repeat itself?
Every 90 degrees, every like 180 degrees.
360.
I don't know. 360, okay.
So this one. So this is 360. What is this?
I'm going to assume 360 divided by 5.
Yep.
And so that would be 72.
72 degrees, which is double 36, because that was halfway.
Yeah.
Yeah. So that period is how often it repeats. Hopefully I'm not talking malarkey. P is 5. Period is 72. That's it. Yeah. Any questions there?
No.
Best we can do there. That's more of this. Let's see. Series of sine. So this is modeling. Sine 60x. That's similar to the previous one. Draw the graph of y equals sine 60x. X is between 0 and 24. So I think that's all right. Write down the number of sand dunes in this model. I just want to see something. So sine 60x. Sine 60x. So that's cray. shift view window. The minimum x, I'm going to say, let's say -6, and the maximum x is 24. So really it should be 0 to 24. No, I'll do 0 to 30, just so I kind of have a little bit. Scale of 90. I don't know if that's... Hey, that's not bad. Look at that.
Yeah.
So draw that graph. Okay. How many sand dunes are there?
5.
Let's see. 1, 2, 3, 4, 5. I think so. Shift graphical. I just want to see root because I extended the graph a little bit. That's 15, 18, 21. So that's 24 there. So this is 24. And so how many dunes? Sand dunes?
24.
Nope. Take a look. How many sand dunes? Between 0 and 24.
Is that 5 or is that 6?
You. Shift view window. Okay, from 0 to 24, exactly as in the question. How many sand dunes?
4.
Yep. And part C.
I'm gonna say, is it something like it's unrealistic that all the sand dunes will be like the same height or something?
Let's take a lookie. 18. So it looks like, so 4 sand dunes. The sand dunes may not all be the same height. Yeah, great. Put it in your calculator. In between, so shift view window from 0 to 24. Any questions there?
No.
I'm sure there's you can do it from first principles as well. Okay, next chapter, chapter 10. How are we doing this?
So factorize. Would I have to do like minus y squared minus y plus 4x plus y plus 4 plus 4x plus 4? Sorry. So do I complete the square or something? Or
Sorry?
do I need to complete the square? Or
No, I don't believe so.
yeah.
They don't all have y in common though. Factorize it. 4 things. What we could do is put these 2 together and then put these 2 together. So what would you get if you factorized the first 2 terms into a linear?
Yeah, would you get 4x and then y plus 1?
And how could you factorize second ones?
Minus y, and then brackets y plus 1.
Any idea how you can factorize it into double brackets?
Do you need to do like 4x minus y times y plus 1 squared?
Just y plus 1.
Okay.
Yeah, they both have y plus 1 in common, and so you can do that. Okay, part B.
Yeah. So should I divide both sides by cos theta?
No,
No.
you'll still have, you have a mixture of sine and cos. Let's see. So you'd have a mixture of sine and cos and tan. What they should have said was hence.
I need to use 4x minus y plus 1 for this, or
Yep.
well, it's not the same format, or sort of.
What is x? What is y?
X is sine theta, y is cos theta.
Yep.
Oh, so we can just do 4 sine theta minus cos theta,
Mm-hmm.
Brackets y, or even, sorry, cos theta plus 1
Mm-hmm.
equals to 0.
Yep.
Do we have to then solve for theta?
Yep.
And so one answer will be arc cos, or even, sorry, yeah, arc cos of minus 1, which is, and also another answer will be
What was this? R cos minus 1?
that will be,
Oh, sorry. I thought you said it. No, go on. If you were doing
and should I do so sine theta minus, if I do sine, or even sine theta equals to cos theta, I think is it something. Oh no, I can't do divided by 4.
just 4 sine theta minus cos theta equals 0.
Yeah.
Nothing wrong with it.
So should I find what arc cos of minus 1 is?
Yep.
That's 180.
Great.
And should I then solve for theta?
Yep.
That would be, I've got quite a lot of solutions. I think I'll go with cool.
What did you mean by solve for theta?
Do 4 sine theta minus cos theta equals to 0 into my calculator.
Before you do that, earlier you said you'd divide by cos. So what would you get if you did that?
I'd get 4 tan theta minus 1 equals to 0.
4 tan theta minus 1 equals 0. I think all of your solutions were probably correct. What were your solutions?
Like quite a lot. Minus 885 point, like,
hold on. Theta is between 0 and 360.
So that will then be 14.0, 194, 370. Oh, and yeah, that's it.
Okay, and I included the 180. So this is question 9 from the next chapter. You're terrifying me with that calculator. Sorry, question 9 from the next chapter. So chapter 10. Question 9. 14, 180, 194. Is that what you have?
Yes. I
Yep.
think.
14.0, 180, 194. That's it. Great. Any questions there?
No.
So this bit was actually a bit tricky. It comes from GCSE. Factorize it into two linears with the same. So factorize the first two, factorize second two, and then if they have the same thing twice, then you can bring them into double brackets. They should have said hence. Let me see this. Express as a single trig function. Any idea about this one?
So I'm guessing this is going to be a lot simpler than using that sine A minus B thing here. There's only one.
It's something that nobody knows. Cos x equals sine 90 minus x.
I definitely didn't know that.
Nobody does.
No.
And so, how can you use that?
Would it be something like 4?
Change the other one. Change the sine one.
So would it be 4 cos 3 theta minus cos x?
What is x in this case?
3 theta.
Yeah.
Oh, right, yeah.
What's the answer?
3 cos 3 theta.
Yeah. B.
So hence solve. Would it be 3 cos 3 theta equals to 2?
Yeah. And I'm going to try putting that in the calculator.
Yeah. I got a couple of solutions as well, but I just need to say the ones from 0 to 360. So I got 16.1, 103 point, or just 104, sorry.
Okay.
Yeah. 136, 224, 256,
Mm-hmm.
and that's it.
Better check question 10. All the way up there. 16.1, 104, 136, 224, 256. They got 344.
I didn't get that.
Oh, your thing just didn't extend that much?
No, I just didn't. Yeah, just that they missed that value out because it closed the bracket.
I'll have to look into see if there's like, because 0 to 360 is very common. So maybe there's some setting that says like all the solutions between 0 and 360 or minus. See, you got lots of negative solutions that last time.
Yeah.
So I think it's getting some negative solutions. You know, there is the other one where you actually solve the thing.
Yeah.
That's not even. And then let's see, they're similar. Let me just see these. Okay. Whoops. There's more calculator stuff. There's more calculator stuff. This one, my guess is you'll be all right. This is what we would need to do next time, I think. Yeah, but anyway, how was that for you, Andrey?
Thank you.
So will we continue this next time?
Yes, please. Yeah.
Okay, so we're nearly finished chapter 10. Yeah, you could see before we were getting like 2 chapters at a time. As they get trickier, it's like 1.5, kind of slowing down. Any questions for me in general?
I don't think so.
All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Okay, see you. Bye.
Have a good one. Goodbye.